Problem number 1. Find the maximum volume of a right circular cone that can fit in a sphere with radius 3 meters. With every optimization problem, what you need to do is start off by doing a diagram. So we draw a sphere and then there's a cone inside of it. So pretty much like this. Now, the key thing here is that they tell us that the radius is 3 meters. But you have to be careful how you draw the radius because, say, this is the center of the circle. If you draw a radius going that way, it's not going to help you at all because there's no relationship with the cone. So the most effective way you can draw the radius is to that side and here. Now, next, what you can do with the diagram is find the height of the cone. So you know that here, this would be the height. But look, once you draw the height, you know that this is h, height. Once you find the height, there's another relationship here because you can see a right triangle. So we know this is 3, this is 3, and we can find a relationship here that this is h minus 3. So we write that, h minus 3. So now we have our diagram. Next, what you're trying to do is find this side here. We can label r because this is the radius of the cone. So we have a formula here. We can use Pythagorean theorem in order to find what r is. So we would have h minus 3 squared plus r squared equals 3 squared. Now the best thing to do here, since we know that the volume of a cone is V equals 1/3 pi r squared times h. We have an r squared here. So what we need to do is isolate the r squared in order to have r in terms of h. So what you do is r squared equals 9 minus h minus 3 squared. Now you can plug that in to your volume equation, and that way you will only have one variable. Next, what you do is plug that in. You have V equals 1/3 pi 9 minus h minus 3 squared times h. That would be your formula. So now you have your equation here. What you can do is expand that using the FOIL method. So you would have 9 minus h minus 3 times h minus 3 times h. You multiply that, you get 9 minus h squared minus 6h plus 9 times h. You can simplify your equation by canceling out the 9's. That way you only have, and distributing the negative, so you will have negative h squared plus 6h times h. You distribute the h and you will have 1/3 pi negative h cubed plus 6 h squared. Now you have a more simple equation and you're ready to differentiate. So v squared, v prime would equal the derivative of that. So in this case, it will be 1/3 pi negative 3h squared plus 12h. That's your derivative. So now you're ready to set your equation equal to 0 and solve for h. So you have 0 equals 1/3 pi negative 3h squared plus 12h. So what you can do is distribute the 1/3 pi to both of these numbers. So you would have 0 equals 3 times 1 is negative 3 divided by 3 will be negative pi h squared plus 12 divided by 3 is 4 pi h. 4 pi h. Now you have a quadratic here, and when you're solving for h, you can use quad form, and once you do that, you will get that h equals 0 and h equals 4. Now going back to our diagram, h cannot equal 0 because it's a length, so we see that the h we're using is h equals 4. Well, we're not done yet because we have to plug that into the other equation. So we know that h equals 4. So now we're ready to use Pythagorean theorem to find what r is in order to plug into our cone equation in order to find the volume. So h minus 3, in this case 4 minus 3 would be 1. So this side is 1, 3, and r. Using Pythagoras, we know 1 squared plus r squared equals 3 squared. In this case, we know 1 plus r squared equals 9. R squared would equal 9 minus 1, which is 8. And r would equal square root of h. Now we're ready to plug it into our volume equation, which is, let me separate here, volume equals 1/3 pi r squared h. Plugging in our numbers, volume equals 1/3 pi square root of 8 squared times h. And h, we know that is 4. Now we're ready to solve. Volume equals, this cancels out with the square root, so it would be h times 4 equals 32. So 1/3 pi times 32. Our final answer, volume, equals 32 over 3 pi. So, answering our question, answer our original question. Well, the maximum volume of a right circular cone that can fit in a sphere with radius 3 meters would have a volume of 32 over 3 pi meters cubed.